Question number 5. Sketched below are the graphs of f of x is equals to ax squared plus q and g of x is equals to a half raised to the power x minus 4. A and B are the x-intercepts of f. The graphs intersect at A and point E lies on the function of f. Okay. C is the turning point of f and D is the y-intercept of g. Now the first question, write down the coordinates of D. So we need to find what our y-intercept is here for the function of g. So we just let our x is equals to 0 and then solve for y. And that is just the same as 1 minus 4 is equals to, what am I doing? 1 minus 4, that's a negative 3. So therefore our D we've got is 0 and negative 3. Let me just say negative 3 there. And then write down the range of g. So we need to find where our function of g, where is it defined in our y values. So looking at the equation of g, we know that this value q tells us that our horizontal asymptote, it's the line y is equals to a negative 4. So that means this line y is equal to a negative 4. Our function of g is never defined in that line. So in other words, we can easily just say our range is when y is an element of from negative 4, not included, up until positive infinity. Or you can say when y is greater than negative 4. Yeah, both solutions are acceptable. And then the second question, calculate the coordinates of A. So at A, that is where our two functions intersect. And at the same time, at A, that's where we have our x-intercept for the function of g. And at this present moment, we only know the equation of g. So let us just use g. In fact, g is the easiest to use at this point. Even if we had the equation of f, it's always best to use g. So to find the x-intercept, we'll let our y is equals to 0 and then solve for x. So 0 is equals to half raised to the power x minus 4. And then I will rewrite this as positive 4 is equals to half raised to the power x. And then now I can rewrite everything as a base of 2. So I can say 2 to the power of 2. And then 2 raised to the power negative x. Now my bases are the same. I can just equate my exponents. So I'll have 2 is equals to a negative x. And then divide everything by negative 1. I'll have x is equals to a negative 2. So that means at the coordinate A, I have negative 2 and 0. And then calculate the values of A and Q. The values of A and Q being the unknowns of our f of x. So in other words, we need to find what our function of f of x is. So we have ax squared plus q. So let us look at all our coordinates that lie on this function of f that can assist us to find this equation. So we've got negative 2 there, right? And we are just given a random point there. So we don't know what our y value is there. So that is not helpful. But the helpful thing that we can use about this point is we know that this is our turning point, right? So if ever our turning point lies exactly in that y-axis, we can use the midpoint theorem. So if ever from this point 0 going to the left, that x-intercept, we've got 2 units. So that means moving from here to that x-intercept again, it should be 2 units. So that means our value of x there is 2. So here I'm just applying the midpoint theorem. So meaning our roots for this function of f, we have x is equals to a -2 and a +2. Yeah, and these points are enough to assist me to find my equation of this function. So I will say y is equals to AA, and then I have x minus 2. Okay, let me just say x minus 2 for this root, and then for the other root I'll say x minus 2, and then let me just write this here. I'll have x minus 2 and then multiply by x plus 2. Now let me expand this. This is going to be x squared and a -4. You can do the whole multiplication, and then you'll notice that our 2 x's will cancel. So now we have that, right? However, we still have an unknown a, and now we can use our coordinate point E, 1 and 3, so that we find what our a value is. So my y is 3, and then the a value, we have that our x is 1. 1 squared is just 1. 1 minus 4, that's a -3. So our a is equals to a -1. And now I will substitute my a into this equation. Let me use a different pen. Let me substitute a into that to find my equation of f of x. I will have a -1 into x squared minus 4. That's just -x squared plus a 4. So our q is equals to a +4. Now determine the length of CD. Okay, CT being the turning point, the distance from the turning point up until the y-intercept of G. So to calculate the distance, we'll just find the difference of our y values. The distance, let me just say the distance of CT. We'll say y at D minus y at, no, let me begin with C. Y at C, let me say y at C. Y at C minus y at D. So y at C, I know that to be, do I know what my y at C is? Yeah, that's just the y-intercept of G. So the y-intercept of G, so if ever that is 0, it's just a +4. Do we have the coordinates of C? Okay, we don't have them, but we can. And how many marks? This is just 2 marks, right? So yeah, our y coordinate at C, it's just the y-intercept. So, and it's just the value y is equals to 4, right? So what you will do, you just say x is equals to 0, and then you'll have a -1 times a -4, and you'll get 4. So y at C, that's going to be the value 4 minus our y at D, that's a -3. This is just 4 plus 3, which means our distance CD is 7 units. And then determine the equation of a straight line through A and D. So we need to find the equation of the line that passes through the points A and D. So to find that, we'll first need to find the gradient between those 2 points. The gradient between A and D is equals to the change in x divided by the change in x. Oh, the change in y divided by the change in x. Excuse me. And then I will use the equation y minus y1 is equals to m into x minus x at 1, where my coordinates are x1 and y1 can either be the coordinate A or the coordinate D. It's up to me. So for now, let us find the gradient. The gradient at AD, I will say my y value at D, which is, okay, I don't have enough space here. My y at D, which is a -3, right? -3 minus my y at A, which is just 0. And then my x at D, which is 0, minus my x at A, which is minus, it was minus, what was it? It's minus 2. It's a minus 2. So this is a -3 divided by +2. So that is my gradient, -3/2. Is my gradient correct? -3 minus 0 divided by 0 minus -2. Yeah, that is correct. And then now I have my gradient, and I will choose to use my coordinate of A, which is a -2 and 0. I will substitute this coordinate into that equation and my gradient into that equation. So in other words, I will say y minus 0. My gradient is a -3/2. And then I will say x minus my x value, it's plus, it's -2. So minus -2, that's going to be +2. Now to simplify this, I will have -3x divided by 2 minus, the 2's will cancel, so that's just a -3. So this is the equation of the line that passes through the point A and D. -2. And now the last question. Do I have enough space here? Let's see. Okay, doesn't matter. So for which values of x is the function of f of x greater than 0? So we'll just go and look at our function of f, and we need to give the values of x where this function is above our x-axis. So where is it positive? In other words, where it's greater than 0. So from -infinity up until this point, -2, our function is negative. Everything here is negative. And similarly, from positive infinity up until when our x value is a +2, our function is negative. So that means our f of x is greater than 0 between these two bounds. It's when x is greater than -2 and when x is less than +2. This is where our function is positive. And then the last question, for which values of x is f decreasing? So for which values of x is our function of f decreasing? So let me erase here. Let's see. erase all of that. Okay, doesn't matter. So when we move from left to right, let's say from negative infinity, notice that our function is going up, right? We are going up here. We are going up, 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 until we arrive at this point, the turning point, where we are neither going up or going down. Our gradient here is 0, so meaning we're just stationary. And then once we start moving from this point C, x is equals to 0 to the right. Notice that we are going down now. We are decreasing, in other words. And if ever we were to draw tangent lines here, you would notice that all of our tangent lines are less than 0. So, which tells us that we are decreasing. So that means our solution states that it's when x is greater than 0. That is when this function of f of x is decreasing. That's one solution, or you can say it's when x is an element from 0 up until positive infinity. Yeah, that is it. That should be enough for you to obtain your 17 marks.